Joe, thanks for picking up your part of the AMD story. Hey, I did spend probably 3 weeks in testing and evaluating the the V620 in Azure, and I want to share the user experience, performance, and cost I captured. I'm Ruben, field CTO at Vision, and bear with me, 15 minutes of awesomeness around UX, performance, and cost. So there are two main topics if you look at user experience. One of them is system performance. What kind of machine performance do you get when you run the OS, when you run the apps? And of course there's the user experience, including remoting protocol, including network, and all the other components. For the first segment, I will focus on the system performance. And to get insights how the machine performs in different sort of instance types, as Joe also mentioned, it's important to know what kind of apps are used. So a short list of apps is here, like CPU-Z, Cinebench, disk, Crystal Disk Benchmark, IO Meter, Blender, as you can see here as well. And then the other list of the AEC apps, so the Architect Engineering Construction applications, Autodesk Inventor, Revit, VRED, Unreal Engine, and Unreal I miss one, Enscape, sorry for that. So Enscape, Inventor, VRED, Revit, and Unreal Engine, these are the 5 apps I use in the AEC type of workload. I also use the macro recorder to record the real user experience and the user interaction with the application itself.
Ruben, I'm gonna
sure.
quickly, there's a video stream of yourself, so your Zoom session is open.
Oh, that's strange. Let's see if I can move that. Not sure how that works.
Good enough, good enough.
Good enough? Good.
Yeah, sorry to interfere.
No worries, thanks. So we're using the Azure platform with the AMD CPU and GPUs, like the NG family, as Joe mentioned, and we're using Vision as the platform to orchestrate and automate and access the environment, and using the frame remoting protocol to access the environment, to run the apps, and also to capture the user experience. All the data I show, yes, is created in the context of frame, but it's applicable to non-frame as well. So if you look at the system performance, also applies to like AVD or Citrix or VMware running on Azure. Alrighty, this will be fun because this will very likely be blurry because of the live stream. We're recording, but in this sort of diagram, this is like my master Excel sheet, where you can see in white the system and the specifications of the machine. And here in blue, with a blue sort of bar, these are all the applications I run. These are like the normal applications running in full HD resolution. And all these colors represent like sort of heat map. Red means not so good performance, and green means great performance. And then here in the bottom, you see my physical PCs, physical workstation with their performance as well. On the right side, you see price in blue with numbers as well. That's the price of the machine, the average price in dollars across all regions, and that gives a good perspective what you can expect from a price perspective on that machine. If I zoom in a little bit better, and this is actually like a couple of months of work. This particular part and also other content which I will present later. These are all the machines I've tested so far. If you look at the NG family, the NG8, 16, and 32, you can see the specifications here. Brand new AMD EPYC CPU, good stuff here. You can see the clock speed, the base clock speed, and the maximum single clock speed. And that is important for single-threaded applications. Like Revit in certain scenarios often can benefit from high clock speed as well. I'm using Premium SSD, doesn't really matter for the results. You can see the driver version, you can see the Windows OS version. So good insights what kind of machines we're using for the testing. Now if I zoom in a little bit better to the dark blue area here, you can see the different applications we're using, from V-Ray on the left to Inventor, multi-threaded. MT is multi-threaded on the right, with all the scores here. And the scores represent multiple test runs of that application in benchmarking mode to get a system performance. Remember when I mentioned their system performance and user experience? The system performance is the angle right now. What kind of performance do in this context, the NG family provide. When running V-Ray, Keyshot, Revit, VRAD, Enscape, Unreal, Inventor, in different modes. I will share the slides. The recording is there as well, so if it's not clear enough, not sharp enough, all good. And I will share the summary of the findings as well in a couple of minutes from now. Now I'll switch gears. We're still in the system performance bucket, but now we'll use a couple of other applications. And these apps are specifically for AEC, like architect, engineering, and construction use case. This picture looks the same. Maybe it's a little bit blurry, doesn't matter for now. Again, same machines in sort of white side on the left side, and then in dark blue, you see the heat map again, but with other applications. Same machines as I mentioned, different apps are being used. Siri kicks in, all fine. So this is like I would say raw data, and probably you can spend like 2-3 hours just diving deeper into that raw data, the findings, and so on and so on. The starting point with, okay, this is nice information, but what kind of information do I get out of it for myself? Is the question, what are you looking for? Are you looking to compare within the same sort of Azure family? Are you comparing Azure against AWS, against Google? What kind of application are you using? Do you know what kind of resource requirements the application has? And with that kind of information, then you plot that to the sort of raw data I just presented. So the raw data itself is a lot of work, like months of work, but doesn't say that much if you don't know your own context. And right now we're just, like I'm presenting, so I don't know your context, but the raw data itself is powerful if you know your context and you can apply that to the data itself. I will share the deck at TeamRGE so you can take a look at the data itself, and a little bit later I will share some notes and observations as well. Now I want to switch to like the user experience side of things. And what I did with the user experience side of things is, okay, we know the performance of the machine, of the multiple machines. We have like 3 family members we tested, the 8, the 16, and the 32. Now apply networking and remoting protocol and other like protocol settings to the equation and see what the real user experience looks like. And if you combine these two, then you know, okay, wow, this works, or shit, this doesn't work well. And that is like the end goal. So what we did in general, but this session is specifically targeted for the NG V620 GPU, AMD GPU, but in general we did a lot of testing with Azure, AWS, Google. With GPU instances, we used a set of 5 apps, as I mentioned. We use LAN and WAN with 2, 4, and 8 Mbps bandwidth. So we are using a network sort of simulation to create different type of like network setups. And we have different network setups with regards to latency and also packet loss. 10 milliseconds, 60 milliseconds, and 110 milliseconds round trip latency. I recorded and captured full HD and 4K resolution, a massive impact. So if you think, okay, this is a great performance, system performance and great user experience, and you capture everything in full HD, and you didn't think about 4K resolution, these numbers are different, like massively different. I also have Excel sheets with 4K resolution, didn't share it here just because of time, but the data is there as well. So understand, if I run 2 screens at 4K resolution, it will have a massive impact on the machine compared to 2 screens full HD. And then color space using YUV 420 and YUV 444, which also has impact mostly on the networking side. Result, summary of that story is there are 40 studies with more than 200 scores, 200 results. I want to show you how that looks like. And part of that, sort of how it looks like, is this sort of player, this sort of web player. This is EUC score from Benny Trich. And this video here is the actual capture of the real user experience using the Azure NGadsV620. And then here, with like from A to H, are like the telemetry data, like the performance data of the host machine. And that combined is interesting because now you know what is the telemetry data, the performance data, and what is the real user experience. And if you combine these two, then you have, like, it's gold. So that's how that looks like. This is like a screenshot I took earlier today of one of these studies. You can access all these studies as well. Right now we're using Zoom and it's being recorded. And that will impact just the playback of what I just showed, for sure. That's why all these studies are on this website. So you can play it on your own machine, no sort of Zoom remoting protocol involved. And that means, yeah, you can access it directly. And it looks like this one here. So let me just go quickly to that one. I'm doing on time, Esther. 5 minutes, good. So ux.dition.com, if I scroll down, you see all the recent studies here. I'll just scroll down for now. I'm not sure if it's sharp with the live stream, but you can go to the website live as well. All the data I'm just showing is live. A colleague of mine just helped last week and yesterday as well to put this all online. And specifically, I'm focusing on the NG32 and NG16 instance types here. You can see it here. So you see Azure, family member, half CPU, full GPU, let's see, 1/4 of a GPU. So there's 3 different sort of GPU types, which region I'm using, and what kind of network I'm using for that particular test. Frame remoting protocol 8, color space, YFV 420, full HD. So if I pick this one as an example, I'll go to this page. You see the details of that test. What is the machine type in Azure? What is the network connection? What's the endpoint? All 3, of course, have impact in user experience. And then you see the 5 apps here. If I click, I didn't prep, but if I click randomly on, like now on Revit, you see what I just explained. You see the real user experience captured with the hardware capture device on the endpoint, the Intel NUC. You saw it in the description. And you see the telemetry data here of running, in this example, Autodesk Revit, using the NG32 over an, let's see, in 8 Mbps network connection, 60 millisecond round trip latency, full HD resolution. I can zoom in, see how if there are artifacts or if there is there anything special. I can zoom into the telemetry data and focus on, for instance, like the average QP. QP is quantization parameter, is sort of a component in H.264. That's the codec we're using in this example. And the higher the number, the more compression is applied, and the more blurriness or artifacts is what you will see. So this is like gold data, and there's so much data I need to stop. It's good, very good stuff, but there's so much data. But I just want to point you to the data, because you know your context, you know your questions, and the data is there. So you can help yourself with the data or ask people in the community to help in understanding, hey, what does this data means specifically? So 2 slides with some sort of findings. So as I mentioned, I spent 3 weeks with the NGadsV620 V620 family, capture system data, system performance data, and capture user experience data, as I showed. And as you could say, it's actually a really great machine. Brand new, like AMD EPYC CPU. Maybe not the highest clock speed, but if you look at just the CPU itself and the CPU benchmarks, it's really performing well. Also the GPU and the combination of CPU, the amount of RAM, and the sort of slicing of GPU is doing well. The entry level, so the NG8, that's the entry level, is like 1/4 of the full GPU. Is great for like design apps, not so much for visualization. So that's something to keep in mind. And also, if you run these design apps at like multi-screen 4K, don't go in that direction. That's like the machine is not heavy enough, not powerful enough, or the GPU is not powerful enough for that. If you use a 16, like half the GPU, great for design and great for visualization. But maybe you're really like finding the boundaries of like the resolution and the amount of screens. And if you go like full GPU, so 1-to-1 GPU, it's doing well. The encoder, so the encoder itself do really well with the latest remoting protocols. There's no decoder on the GPU, so if you're using like YouTube for decoding in your VDI session, no go. But for encoding, works well. All the 3 partitions work well with encoding as well. And then if you look at real-time ray tracing, check if the application requires updates. Check if the AMD driver is up to date. And if these 2 are up to date and you cannot use real-time ray tracing, then very likely the sort of real-time ray tracing is not supported by the V620 AMD. That's what I've seen as well. Overall, the NG performs slightly better than the NC family. Of course, it really depends on which application you're using. But if you look at all the data I showed earlier, it is sometimes better than the NC family, the T4 GPU. Sometimes like slightly not compared to the NC. But overall, if you look at all the data, it's really a good machine to use. And the same applies if you compare it with the NVIDIA's A10. So that's an A10 NVIDIA GPU and slicing of GPU. Of course, it could be a mixture of like GPU and CPU. But if you look at all the data, it's really a good machine to use. Then you have like a little bit, in my opinion, odd machine, the V620 V1 with like a massive amount of RAM. Maybe probably there are use cases. Otherwise, they wouldn't create such a family member, but I've not seen usage for that type of machine in end-user computing yet. Side note, I was surprised, actually negatively surprised, by the price. I had expected that the AMD powered instance on Azure had a lower price compared to the NVIDIA powered machine. Why? Because there's no licensing involved. So I was a little bit disappointed on that side. But it is what it is. And what I understand, not sure if that's official, but what I understand somewhere is that it's mostly because the GPU board itself is pretty beefy from a power consumption perspective, and that has a massive impact in like the cost calculation on the Azure side of things. And also the availability of this family member is also attention. There are regions, as Joe mentioned, where this machine is available, but it's not like massive in all regions. So yeah, that's always an attention point with GPUs, but specifically for the NGadsV620, that's extra attention. With that, great. We did it. Thanks, Joe. Thanks for your help, and thanks all for listening, and see you next time. See ya. Bye-bye.